and we'll go from there. Okay, for those who don't know, my name's Dan Dorfmuller, and some people call me Dorf. That's my nickname, came from Baker Concrete Construction because it was Dan Baker and Dan Dorfmuller, and people got tired of distinguishing between the two of us. So anyhow, we're going to talk today about print reading for concrete inspector. And the purpose of this class is to get these inspectors just a little bit better prepared for taking the test. At the end of this program, hopefully you'll feel a little bit more comfortable about opening up a set of drawings, graphic languages, lines, symbols that are involved in construction drawings. And you'll be able to locate on the drawings such things as plans, sections, and details as it relates to print reading for the inspector exam. And we'll take a little bit of time where we're going to look at some sample drawings to use for the test. But one of the things that I like to tell people when we're getting started into understanding drawings, there's two things that have to go on. One is you've got to be able to kind of get this graphic image inside your head. That's what pictorial drawings are used for. And then the second part of this is the orthographic projection, the old-fashioned way. I think we have Mark here. Welcome, Mark. Which would be the CAD and the BIM that everybody's used to doing today. Now, the reality is drawings are, basically speaking, are created in these CADs and these BIMs, but when they come out, they look just like we used to always do in our those of us who are old enough, T-square and triangle type of a work. So, for instance, if you saw this house and now you've got an idea of what this house is going to look like when it's finished, but you can't build it from that. Therefore, you have to have some plans, sections, and details. Same thing here with this office building. Elevations help do some of the same things. They give you a graphic image of what the building's going to look like when it's done, along with some of the materials that might be involved in the finishes on the exterior of the building. Sometimes this can be found on the title sheet. Orthographic projection, I think it's interesting to understand kind of how that is actually pulled together. That's by looking at the top, front, side, back, and cutting sections through a building. If you look at this house right here, this simple house shape right there, you'll see how it's projected out, coming out this way here, out this way here. This little piece right there is the roof, and it shows you the gable on the side and the extension of the house over here, and over here is a flat view picture of the roof. That's considered orthographic projection. Now that's a real simple BIM drawing. In BIM today, we just take this whole thing apart and we create the drawings from it. And when you're done, you have plans, elevations, sections, and detail type drawings. Now, if you're looking at a set of prints, we're trying to identify the types of drawings. Civil drawings is usually in the front of the drawing, front of the set. Then you'll have the architectural, the structural, mechanical, includes the plumbing and electrical and things of this nature. And where do you find all this information? Well, you find this information on the title sheet. And the first thing that I've always gone to, I've been an estimator, I've been a builder, I've also been a consultant, I've helped people in legal situations, and where I always start with everything is I want to know what is in that set of drawings. So you find it there. And blowing that up a little bit closer, you can see it starts again with the civil, then the structural, then the architectural, mechanical, electrical, plumbing, and so forth. The other nice thing there is to note is when were the drawings all issued. In this case, they're just showing you the issue for permit drawings. But every time a drawing is changed, you will see a different dot in these things with a date on that. Then you move on to the civil drawings. Well, the civil drawings are the drawings for that information that's outside of the building. So the building pretty much is just going to be showing a kind of a nice, dark, solid line around the property, and it might also show a change in the elevations, the roof lines and things of this nature. but it's showing all the stuff outside of the building. And here's a much bigger site plan of a much bigger facility. And then the floor plans, which is the beginning of the architectural, almost all jobs will start off with, although it may have some general notes, but it typically will start with the floor plans, starting at the lowest level and work its way up through the building. And the floor plans are nothing more than kind of looking at that building as if you were standing up about waist height and you just cut a big section and you're looking straight down on top of it. Also, a nice thing to note there is also gives you all the column line identifications coming across the top. One set of them will always be numbers. The other set of those identifications will be letters. And you'll note there'll also be some offsets like this here we have down here, 0.5. So we have column line 1 and there's something off a little bit to the left of it. So they're making that 0.8 or 0.5. Here we have 1 and then 1.3. So it's just a way to get a person to be able to find where this information is on the drawing. It's actually used, floor plans are used kind of like as the access information to everything else that you're going to look at on the drawing. And it's also where they show you where the, we'll call it plan north is, and they'll also show you where what the identification is for the scale of the drawing. And here we just blew up that mezzanine area over there in the corner of that warehouse. Elevations are doing the same thing that the floor plan's doing, except now we're just taking a walk around the building and looking at each one of the different views. And this is where the plan north is kind of nice to know. Here we have the north elevation, what they call beyond, and the north elevation. So this building obviously is stepping back a little bit. And you can have interior elevations also where they're showing windows and how conference rooms and things of this nature are going together. And then you have sections, and sections can be whole building areas. They can just be an area, for instance, where between a couple of column lines showing where the stairs are going up to the building. And then you might have some, even blow up of these section areas, which would be considered details. And then you get into details where you blew up. So we're always going from kind of general to more specific, into even more specific, into even more specific. So you can kind of like zooming down into looking at a certain portion of a drawing. So here we're looking at a dock leveler. That's all we care about at that moment. Sent the guys out that day. I want them to go out and build the dock. Then you see other kinds of details. Sometimes details are typical details for different kinds of things in a building. So other ones are real specific. Then we get into the schedules for a job, and you have room, door schedules. All pretty much familiar with that. Room finish schedules, column and beam schedules, where you'll show sizes and numbers of rebar. And even in the drawings that we'll be looking at in a little while, they have little schedules for different portions of the building. So that simple door schedule where they identify every room in the facility, tell you what the door type is, the size of the door, the thickness, materials, finish, and over here off to the one side, any particular notes. Same thing with a room finish schedule. And notice this is why you need to know plan north. They only tell you what it's paint or glazing as you walk through there on the north, east, south, and the west walls. Now we get into the concrete. See markings for footings, footing 1 through F, and then they got, a couple of piers, pier 1 and pier 2, tell you the different sizes, the reinforcing that goes into it, and what the elevations might be, and some general notes. Pretty simple footing schedule, but if any of you guys have been built, and I'm sure you've been on big jobs, they get really complicated really quick. And same thing here with a concrete column schedule, showing you all the different In this case, they marked them column C1, 2, 3, 4, and 5, 6, and 7. They tell you where they start, and they tell you what floor they actually go on up to here. Then you have structural drawings. Structural drawings are going to show you, which are the S drawings, the concrete, the wood, the steel, and again, you break it down into sections and details. Always start off with the foundation plan. The foundation plan shows you all the concrete that's in contact with the dirt or the substrate materials that are involved there. I think this is still a pretty simple foundation plan because they put the footing and the pier schedule right here on the same page. And notice that they still have the column lines 1, 2, 3, 4, 5, and 6, and the ABC. So now we know, how everything relates to the architecture and the structure, so you can put those two components together. Note there, it tells you what the foundation plan is, and it tells you what the north arrow is, and it tells you what the scale of the drawing is. And over here, it tells you, this is typically where you'll find some of the basic slab information. It tells you the warehouse slab is 6-inch reinforced concrete slab with fiber mesh over a 4-inch compacted granulator fill, and it tells you what the elevation is, 100. And it also tells you what the, I believe that is telling you what the elevation is in real life. And here they relate the 690, 697 at probably 0.5 feet to elevation 100, because it's a lot easier to deal with something that's 100 and going up and down from there than it is to try to figure out 695.5 or 697.5 and do all the math from that particular point of view. When you're looking at the framing plans, obviously they're going to show you the wood, the concrete framing, the sizes and location of beams, the floors and thickness, the reinforcing steel, structural steel framing, the columns, the beams, the steel deck, all those things that go involved in building that frame to hold all the architecture. Here's a typical framing plan. This is above the foundation plan. So in this case, this is they're just showing you the mezzanine framing of that one particular area. So you're looking at D, E, F, and G, and 1, 2, and column 3. So that's those little mezzanine area. And as you can see, there's a lot of details going on there. Again, you'll find the slab information, the concrete information over here, showing you what the floor is. And then as you move on through the prints, you'll find mechanical, electrical, utility, plumbing, heating, air conditioning, and all the other gingerbread stuff that gets involved in going on all the structure and in between all the architecture. We won't worry about plumbing drawings, but plumbing drawing is nothing more than just overlaid on top of the architectural drawings. And back in the old days, why do we call them blueprints? Well, we call them blueprints because they used to be blue prints with white lines on them. They used to draw them with pen and pencil, and then they would run them through the vellum and ammonia and make a tracing, and then expose them to the ammonia, and everything would turn blue, and the rest of the lines would turn white. It's kind of hard to find them anymore, but it's funny how almost 100 years later, it seems like we still call them blueprints, don't we? An important thing about handling prints, never write on the prints unless you're making authorized changes. Keep prints clean. Don't eat or drink over the top of them. Some people don't seem to realize that. Don't fold them. Roll the prints up carefully. You fold them, it makes some creases in them. If you fold and unfold, fold and unfold, it gets to be a problem. Don't lay sharp object on them. Don't leave them out in direct sunshine. And store them in a nice, clean, dry place. Like these people here. They just love their drawings. Understanding the alphabet of lines. Remember, drawings are really nothing more than words and a bunch of graphics on a plan. So you have a property line that looks like this, a long dash and 2 dots, longer dash, 2 dots, long dash, 2 dots coming across there. You'll have a border line, which is usually identifying around the page. Some people put that on, some people don't. Then you'll have your object line. The object line is the main line of a wall or a window or something of this nature. Then you have hidden lines, and hidden lines can be something below, like at a slab. Some people like to put foundation plans as hidden lines, where they look at it as dirt and the slab is covering up the foundation, so they do them as dashed lines. I prefer not to show them that way when I draw them, but that's how some people do show them. And that's a little fainter of a line. It's not quite as hard. And then you have center lines are showing you the center lines of all the column lines. And you'd also have dimension lines and things of this nature that are showing you kind of a little bit fainter on the drawing. As shown here on dimension lines. Dimension lines obviously can have arrows. They might have these little dots at the end. The arrows might be inside, as you see up here. They might be on the outside. Your dimension in this 8-inch showing you between the lines might be 0 foot 8 inches, which is actually the way I like to do it. Then you're real clear that it's 0 feet and 8 inches. And sometimes you'll put it out and do a little leader line coming over here to show the 8 inches. In most drawings today, this is what I see. I see these little tick marks. I realize my mouse is a little bit jerky. It's not so jerky on my computer, but it's a little bit jerky here on your probably on your computers. You have what they call break lines. So if you have something that's going to go on for a much longer distance, you'll show something that shows a break line, meaning that there's some more to this, or this wall or a piece of this structure continues to go on out. Or for instance, real typically, you might see a caisson that shows this little curl to it like that, little swiggles, almost like an infinity line, and the caisson continues to go on down deeper into the earth. When you're going through a set of drawings, obviously you're looking frequently. You'll see in sections and elevations, you'll see what they call cutting. The legal name for this, or the official name, is a cutting plane line. So you'll see an identification of a section number up here, and on the lower portion, you'll see a section number identifying where the location is on the different sheets. Or if it's a real simple drawing, like some of the ones that we're going to be looking at in a little bit on the print reading for inspector, you might just see A, B, B, C, C type thing, where it just shows a cut all the way across it. And every architect an engineer has their own specific way of doing this. Some like circles, some like squares, some don't put anything, just put a number on the top, put a number on the bottom. So, but basically speaking, it's like walking inside of something, and you know, in this particular case, you'd like walk inside and you're looking up that way to look at a particular section. These kinds of things should be identified on the cover sheets or someplace that tells you how the different marks are and what they're going to look like and what they mean. Like, for instance, a revision mark or an elevation mark, or here's an elevation, meaning something you're looking at in elevation, or an elevation mark tells you what the different level is. So it tells you what your wall marks are, your door marks are, your window marks, and so on through the building. And you might find some material legends also on there. And as you're looking at it, here's a floor plan, and you can see that this would be considered the object line. This little dash line here, what does that little dash line mean here? Well, that you're not identifying something that's hidden, because there's a leader kind of coming up off of it with a section 1 on sheet 6.10. So that probably means that detail's been blown up someplace. Here you have a section mark. Instead of putting the arrow down here, you've got the arrow mark up there telling you to go look at detail 2 on sheet 6.06. And this is where you'll find the dimensions. Now, in this particular case, you see a little dashed line coming across here. And without actually giving a little bit of investigation, I'm not sure what that means. It could be something above, could be something below, but you'd have to go look at this little note right here that's it's got a little square that says go look at note number 8. And they use this kinds of post-shame just to identify different types of materials on jobs. Like for instance, this job here was for these different colors. The building materials, again, part of the graphic language of drawings is all different kinds of, like I call it pochane. So you can see concrete in section might look like this for block, cast, cinders, fire brick, slate, stone. And in elevation, it might look a little bit different. There's cast concrete, there's block concrete, there's brick showing as closer together lines. You might see brick in here as bigger lines. So you got to look at the legends of each one of these types of materials, and they should be on some architect's sheet in the general notes. I can't say they all do it that way, right? And there are just a whole bunch more building material symbols. Same thing goes for exterior topo symbols. There's some earth symbols and bad insulation. Here's they're showing you some different pochane on this job here, showing you what some of these different materials mean. And you get different symbols for plans for windows, and basements, and laundries and sink. Now I realize you guys probably get all this stuff right now here, but I have a lot of students who don't understand, they've never looked at a set of drawings in their life, so I'm still going, taking a little time to go over this. Same thing with plumbing drawings. Now here's one of the things I find gets people into trouble sometimes. They look at some symbols and they're looking on a exterior site plan drawing, and they might see something that looks like, oh, maybe something like this. And you got to make sure they're looking at a plumbing drawing because it might be something else on an electrical drawing. So you make sure make sure that you understand the symbols that go with the type of drawing that you're looking at. Notice down here they have see a long line and two dashes, a long line and two dashes, and here that means a hot water line. And what did I tell you that meant earlier? That meant a property line on a survey plan. HVAC type stuff, electrical type stuff, symbols. So how do I find information on drawings? Well, the most important thing I think is start off by looking at the title sheet. And this is what I tell all my new students: flip through all the drawings, all of them. Now, if you're a subcontractor or like you guys, maybe you're out there doing certain things on a job, not the entire project. Maybe you want to tag out some of the pages that have the information on it that you need, and then highlight those or color those areas in for either your scope of work or for whatever the type of inspection that you're doing. So let's take a real quick look at specifications. I don't know how much time you spend into looking at specifications, but I would imagine you're probably spending, you're making sure things are applicable to a certain set of specifications. The specifications are written statements that define the extent of the quality to be done and the materials to be used. They are supplements to the drawings. And this, hey, we all call them specs, and some people call them the funny papers, right? It's written under the format of the Construction Specification Institute. The old division system had 16. The new one has 49 divisions. Not all 49 of the divisions are being used at the moment. The divisions that are being used is Division 1 for general requirements, 2 for existing conditions, 3 for concrete that you care about. Masonry, 4, metals is 5, wood is 6, thermal and moisture protection, which includes roofing, is 7. They've got this new one here called openings. Finish has always been 9. Specialties has always been 10. Equipment, it's always been 11. And furnishings through some of these others, or some of the new ones, 13 is now special construction. You have to go look up and see what's involved. Conveying systems, elevators and escalators. 21 is fire suppression, so they broke that out separate. 22 is plumbing. They broke that out now separate. HVAC is 23. Electrical is 26. 27 is communications. And on God's earth, I do not understand why they took and put earthwork as 31 instead of the old Division 2. But that's what they did. So that for me has been hard to wrap my head around. 32 is the interior improvements, and 33 would be utilities. And what we mostly care about is concrete. And by the way, if you want to get a breakdown of all the different divisions, you can go over to www.csinet.org and click on the format, and you'll find a whole bunch of, you'll find the entire breakdown. The concrete breakdown looks like this, where you start off with 03000 concrete, the 030100 is maintenance of concrete, and you get all the way down to the other end, 033716 pumped concrete. So, and you can see in between all that, they got a whole lot of concrete. Not every set of specifications includes all those, but they're all there.
Hey, Dan.
Yes.
I'm sorry to interrupt you. What's that website again?
Go back. Actually, if you just type in CSI or Construction Specifications Institute, you'll find it.
CSI.
Yeah, Construction Specifications Institute. And it's worth getting familiar with some of that stuff. I don't know how much specs looking at both Ed and Mark do, but a big part of my consulting job and a big part of my legal work that I get involved with is actually looking at the specifications, which helps define the expectations that an owner might have. And maybe that from an inspection point of view, maybe it's the same thing. What are those expectations? What are those limitations? What are those variables that you're allowed to have? What is that gray area that you're allowed to have, we'll call the minimum and the maximum for some of the inspection specifications that you're supposed to look at. I call this the anatomy of the specifications. Almost all specifications are broken down into these basic categories, which is related documents. So when someone I do a lot of teaching of subcontractors, so someone will tell me, well, I don't need to worry about bidding, the concrete construction part. No, you don't. You need to look at this because you are responsible for everything in those set of specifications, because right in the first thing that they'll usually tell you is that all the related documents, you're not just bidding your section, you're bidding the job as it relates to your section. So you've got to be very, very careful with some of that. You've got to look around. Then sometimes they'll have the summary of the work, related sections where they're very specific about telling you what it is. Definitions simply means words that you think mean one thing that might mean something else related to specifications or that particular sections. References can bring in, we're not going to look at too many. In fact, I don't think we're looking at any specifications, but you just take ACI 301 or a ASTM number, and they'll just give you a couple of those things, and all of a sudden you've pulled in, 2 inches of documents that you're also responsible for, with a 1 or 2 liner on it and a reference situation. Typically, they'll give you a little description of work. They'll tell you what the quality of the work is supposed to be, so that would be something an inspector should want to look at. The type of submittals, and I don't know if inspectors look at submittals or not. Special inspections, this typically means that, when you're looking at getting ready to bid a project, they'll tell you you're responsible for actually going out to the job site and looking at what you're going to have to be, where that job is. So you can't come back and say, well, I never saw the job. Well, it doesn't work like that. You've got to, I know I was working with some guys that build water towers, and they had to literally travel across the country, make a special trip to go look at this little, usually ½ acre to 1 acre little spot that these water towers are going to go look, actually going to get built on, so they can say they saw the job site. Project conditions, which kind of goes along with the special inspections, the types of products where you have a whole list of the products, how the job is going to be built, which is execution. Protection, I want to go back here. I tell my subcontractors, you better make sure you understand that very, very well, because if you don't understand how you're going to protect the job when you're done with your scope of work, they can actually make you protect it the entire time until the job's turned over to the owner. Of course, maintenance and warranties. So when you're looking at related, we talked earlier, we're looking at related documents. When you're not just bidding the structural drawings, you're bidding everything that's related to also to your stuff in the architectural drawings, including general and supplemental conditions, how you're going to get paid, how the retainers are going to work, insurance certificates. The summary is just what it says, including other sections of it, definitions, and I explained to the concretes, like, does anybody understand what F numbers mean? If somebody would just open up a set of specifications, would they really understand what F numbers? Well, this is where they might define what F numbers might actually mean. Talking about reference material, ACI, ASTMs, PCA, and those kinds of things. So you need to be familiar with all those particular documents. The description of the work, similar to summary, with more detail telling you what's involved. It might tell you that you're responsible for the sub-base prep, some formwork, some caulking, maybe some layout. Here's where quality insurance falls in. This is where you guys probably get a little bit more involved. Is the installer certified, for instance? Does he have the right experience? Does he have to build mock-ups? How do approvals get taken care of? Are there pre-installation conferences? I don't know if you guys as inspectors get involved in that, but I would think if you're working for the city, you probably do. Submittals, and tell you what, you can spend an awful lot of time. This is what, when I was young in the business, they used to come in and say, hey, Dan, could you get together these submittals? Well, shoot, I could spend several days to a week in getting together all the tech data, the color sheets, whatever was involved on, especially on a major general construction project. There was a significant amount of submittals that had to be turned in. Special instructions is pretty much what it is. Project conditions, you're accepting the site conditions, what kind of storage you need, what kind of layout, what kind of access you're going to have on a project. So it's a lot different if you're out in the suburbs than it is if you're downtown in a major metropolitan area. Products. What are all the specified products? Some are basis of design. Some of these things could be, hey, this is the product you got to use, and that's just the way it's going to be. Protection. This is where I think a lot of people get involved. Who's going to be responsible? I say read it, qualify it, or weep. Maintenance. Nowadays, most owners want a whole maintenance manual, understanding what is it going to take care of my building and all the products that have been put into it, and so that they understand the maintenance programs and how it's going to work in the future. Warranties. How long? When does it begin? What are the repairs? What are the conditions of the repairs, and what constitutes a requirement for repair? And I've been on projects where the typical one is, is 1 year. Well, there's an awful lot of people out there now are requiring things for 3 years, 5 years, 10 years, and 15 years for some of the warranties on some of the things that are going on. And the last one is cleanup and repairs. When is the work to be accepted? And most of the time it's not accepted until final payment's made. And the owner says, I accept the work. So going back to reviewing a concrete set of drawings, what's the first thing I suggested doing? Well, flip through all the drawings and understand try to get that visualization into your head. Check the specs for your key items. And when I work with young students or young people getting into the business, I actually would throw down a 3-inch set of specifications And I would tell them you got the next 2 days to familiarize yourself with this. And I don't mean read every word, but I'm talking about flipping through every page and skimming those specifications, beginning to get an idea what's in there. And then I would dream up some crazy questions to ask these guys and see if they had an idea of where to find this information. It's not a matter whether they knew the answer. It was more about, can you go back and find that information that you happen to need based on a certain question? And then, of course, I like to tab things out as I go. Where are the architecture? Where's the structure? Where's the foundation plan? Where's the different things that I'm interested in? So you should have gotten a copy of this PDF that I sent to you guys, which is some questions that we're going to look at. So here we are. This is the drawings that you have been given to go find your print reading for inspector questions, and I understand there's 20 of them. How long do you get to answer those questions?
1 hour.
You get 1 hour, okay. So what's the first thing you would do? I know does everybody have your mic on? I know Mark, Ed's on, Mark's not on. I don't know if Mark can get his on. So the very first thing you would do is flip through the drawings. I think you have like 15 drawings, 12 or 15 drawings that you have to flip through. Now I'm going to drop out there, Mark. I'm going to drop out of the PowerPoint for a minute. So the very first thing you would do is flip through those drawings. And you can see drawing number 1, but figure 1, basically speaking, is just showing you how rebar or beams are tied together. Just a bunch of typical stuff. Page 2 is how to fabricate, what are all the different bend marks for a type of rebar. That's all that stuff means. I don't even know if there's any questions related to it because I have Luke. Luke didn't pass anything else on besides the few that we have that you saw earlier.
Dan, can you hear me?
I can, Luke. I'm glad to hear you're there.
Yeah, this is Luke.
Okay.
Yeah, I'm here. Just a couple of things. They are given 15 minutes before they start the test to look at the drawings.
Good.
So flipping through the drawings is very important. What we're looking at right now are out of ACI 117 and out of the CRSI book.
So that's what you're looking at, and Luke tells me that eventually we're going to have some newer drawings to look at, or some more contemporary, we'll call it, drawings.
We're about probably a year or two away still.
It's okay. I'm gonna eventually get this thing done, and then when we get, my goal would be to create a video for it, and that people can actually just go look at. So in case Mark's schedule didn't line up with Ed's schedule, they can go look at it on their own. But you still flip through the drawings. And you'll just be noticing that your typical bar bends. Then you get into your first drawing, E1, and they're showing you a plan, and you notice that they have section cuts here, telling you GG, just like the old-fashioned way of done it. These things were probably done with pencil marks, that kind of a thing. So that's what I would do, and I just skim through them. I see, I know G's here, and I'm looking over there. I see there's where GG section is, and that's through. It looks like it's through. I'm not sure if it's a grate or what's going on. Probably a grate up there or something, huh? Because there's a little slab down there. Sheet 2, you've got a column schedule for an outline of that. I have no idea how this sheet and this sheet actually go together, but they apparently do.
And before you leave that,
yes.
These sheets do not relate to each other. Each one is an independent sheet.
So, but that's helpful. So you're just pulling off. So that's why these questions say, go look at sheet whatever, and you go from there. Okay, good. So sheet 3 is another type of a drawing, and it looks like it's some kind of a slab drawing with some different beams in it for some kind of a high school. And sheet 3 or 4, E4, we've got a beam schedule, some kind of a 5th floor of a framing plan, so it's an elevated deck or something with some spandrel beams off to the side. Sheet 5 It tells me I'm a second floor framing plan. I see a beam schedule. If we want to blow up, where's my little blow up piece here? I thought I had that. My loop, where'd my loop go? There it is. So you can come over here and I can blow that up. Okay, tell me I got number 11, I got 11 number 4s doing something there, and I got 10 number 4s doing something there. So, and over here, I've got something going on. All right, pull that back out of the way for a minute. Here's another framing, a typical beam and girder framing plan. And up there, they tell you what the schedule is for it. Next drawing. I have no idea what that's supposed to do. Wastewater treatment. Okay, so this is probably full of poop, and the water level comes up to here. So wastewater treatment. And over here we have some more wastewater treatment sections. And here we have 6th floor framing for an office building. I'm showing you some of the structural layouts. 6th floor there. Seismic framing. Some columns. Some shear walls. Things like that. So you can kind of see how I'm going through it. So you just flip through there. Of course, you don't know the questions. You don't, Luke, I guess you don't get to look at the questions ahead of time, right? Before they pass that out?
No.
Okay, all right, so thank you for that. Anyhow, that's how I would go through them. I would just get through. It'd be nice if you could look at the questions ahead of time, but you can't. So going back to the PowerPoint here. Poof. All right, so if we look at question number 1, I don't know, we'll probably just kind of go over this together. It tells you to go to sheet E1, which is not that one. 1, 2, 3, E1. Okay, so the first question says on GD1, answer the following questions. What is the typical interior footing designation? Okay, so the answer to that question would be F1. And rebar number and size. Oh, and what is the size of the footing? So how do you find that? Well, you have to go find the footing schedule, for instance, down here, which is marked F1. And you can see that that's a 9 foot by 9 foot by 1 foot, 1 foot, 11 inch deep footing. That is like, who in the world? That sounds like an engineer, doesn't it? We're going to pick on Luke for a minute. Luke, would you design a footing that was 1 foot, 11 inches deep? Nah, you wouldn't do that. You'd make it 2 feet. I know a contractor would. And then it asks for what the reinforcement is, which would be 10 number 8s each way. Okay? Question number 2 says section BB, answer the following questions. On elevation, what's the elevation? Top of footing. And it's a little bit confusing as to what that really is for BB. Yeah, for section BB. So first thing you do is go find BB in section and BB on plan. So there's BB on plan. And it kind of comes around the corner and goes up this way. And you could even assume that it went all the way over to here, where it turns into section CC. At least that's how I would read that. You would read it going around the building in this direction. You would say that CC went from here to here, and then it's obviously different at DD. And then I would be inclined to think that CC picked back up there and went on around to here. To me, it made more sense to put the CC back over there to make sure it was clear. But anyhow, back to the BB part. So you can see here it says 92.33? I think it's 33. And it's minus 6 inches for a slab, minus 6 inches for sub-base material, So top of footing would be 1 foot less than that. So it'd be 91.33 feet. But over here, I noticed it says 90.33. So I'm not quite sure what that means. That might mean it just stepped up a foot and then stepped up another foot over here. So that's a little bit of a confusing question to me. But
so what is the elevation?
I say it's 91.33, and you could argue that pretty strongly. 91.3, because it's very clear. It says per section BB. So you see it 92.33 minus 6 minus 6, so it's 91.33. How is the structure tied to the tied into the wall? So you've got up here at the top, the top of the structure is tied in with a number 5 at 12 inches. It's got a 2-foot hook and a 3-foot hook. I would suggest guys bringing magnifying glasses with you too, because sometimes you can blow them up a little bit and kind of get a feel for it. All right, well, let's move on with the questions that at least I have here. On sheet 2, let's see here. Sheet 2, I said, how do we go? What I do, go back one too many? There we go. On sheet E2, answer the following questions. What size is the northeast column between third level and roof? So the very first thing is you got to find out where is the key plan for building A. Well, it looks like it's right here. And the north, to which way is north? Well, it's straight up, and east would be off to the right, and west would be off to the left. Of course, south is straight down. So that should be this column right here, what they call column number 8. So the next thing I do is come up and look at the column schedule, and they got the column marks 1, 2, 26, and coming across here I see 7 and 8, and they're telling me there's 2 columns like that I don't really care about at the moment, because the question was, what is the size? And the side is 14 by 14, and you'd have to assume they mean inches. So that's the answer to that one. What is the elevation change between the third level and the roof? Well, the way to find that is you have to come over here to the columns, and it tells you that you're in the basement, you're first floor, you're in second floor, you're in third floor, and then you're up here in roof. And it tells you the roof elevation is 134.5 feet, and it even has this little mark there showing the arrow up to that edge. And the top of third floor is 129.5, and if you subtract those 2 numbers, you come up with 11 feet. So you'd find the difference in that elevation is 11 feet. What are the tie sizes and spacing? And so you come back over here to column 8, and it tells you the ties is ties and spirals followed all across. You'd see their number 3s at 12 inches on center. Any other questions that you remember based on this set of drawings here?
Dan, there's one thing that I wanted to point out. There is a question, I believe, on the spacing of the ties or the spiral. I forget which the question is. And as you see on this one, they have both round columns and they have square columns. So it's easy to get the wrong information if you're looking at the wrong size column. I just want to make sure they realize that, the difference between the spiral
let's look at
distance and the tie.
No, good. Thanks for pointing that out. I may add a question to this in the future. So 13 looks to me like a round column. It's out here in the middle, right? So we'd come up here to 13. It says it's a 20-inch round column. It's got 8 number 6s, and it's got 3/8 inch round rebar at 2 1/4 inch. I don't know what that. Presume that means the spiral dimension is your spiraling around. There's 2 1/4 inches between each spiral. Does that make sense to you?
Yeah.
Luke? Okay.
Yes.
So
yes.
That's how you would answer that. So it's 3/8 round at 2 1/4 inch apart on center. Doesn't say on center, but I'm sure that's what that means.
And how does that differ from the other ones you're
Okay.
saying?
All right, so look at this column. So anyhow, to answer Ed's question, look here for the square columns or the rectangular columns. You see rebar. There's your tie coming across. And these are at 12, they're saying they're at 12 inches on center. So from there to there to there is 12 inches. On the spiral columns, and that's a number, they're still number 3, so they're 3/8. They're wrapping around and spiraling up this column. And from this distance to this distance, if you can see what my mouse is doing, that's a quarter, 2¼ inches. That's the difference between the two. That makes sense? Okay. So you can see here, there's a round column, and this little outside bar is considered the tie, and it's spiraling up the rebar cage. When you're over here in rectangular, you're looking at ties that just wrap around horizontally, like here, here, and here. Okay?
Okay.
Permission to go on.
Good to go.
Good to go. All right, so the next set was on E8. Okay, I didn't hear from Luke. I'll have to ask that question.
There's a question on this too, and it's something to do with the spacing up at the top.
On E8?
On drawing E8.
Okay. Well, I got a couple questions here that were given to me. You know, what is the specified strength of the concrete? And that really should be pretty easy. It's typically, if it's not just, written out, it's right there. All concrete shall be 3,000, 28 days. And then what is the bar size and spacing of the outside walls? Well, that should be pretty easy too. You just come over here and horizontally, they're number 6s at 12 inches, and vertically, they're number 7s at 12 inches. Now, you said something else about spacing. Do you have any idea what that spacing question was?
I can't remember right now offhand. There are some questions like that, though, that are in the general notes to do with finding those that are fairly easy. But then when they get into, say the very top section of, I think that says 189 and 4 inches, and then you go off and then it's 6 foot, and on the left is 7 foot. I don't know if they add or subtract the actual distances.
They're asking you to do the math for between column lines. Do you know how to find missing dimensions?
Yeah.
I'm not sure I understand your question here. Well, okay, so you have an overall length. You're talking about like 109 to 129 foot 4 inches. Is that what you mean?
And is that what that says? 129 and 4 inches.
129 and 4
is that 1?
inches.
Okay.
It could be 189, but I think it's 129 because the one below it looks like 127. So that would make sense. It's 129 to here minus, they're coming down on the right-hand side. They're coming down down and over a foot. Okay, so that makes this 127.4 because they're taking a foot off of here and a foot off of here. So if someone says, I'm trying to think of what a good question would be. Well, when I'm working with dimensions, I figure out what do I know, okay, and then I begin to subtract what I don't know from other directions to find the whole. We'll call it the missing number. I thought I have a video on that someplace, but I don't remember where it is. It could be on YouTube.
Okay.
But, as far as, other spacing, the bar that's coming across the top here is number 5 at 12. And then they're saying these bars that are running kind of along this long length there, those are number 4s at 12 coming across. Okay, so that's pretty simple stuff. Top of this is 3 feet wide. Okay, so someone could ask you what's the distance from here and the opening from to there. And if they don't give it to you anywhere, how would you figure that out?
The answer for 3.2, when it's asking the bar size and spacing of the outside walls, where I know you have it highlighted under your 3.2, but how are you knowing that that's the area?
Oh, well, it's the only answer that could be. They didn't ask you what the tie bars are or the hook bars are, all this stuff coming up. See all these bars that you see down in the footing, they're coming across and then they're angling up. So those are really footing reinforcing. It's not wall reinforcing. They're just tie bars. So if you look at the plan above, there's the plan. Here are the out. How did I end up doing that? Let me go back. These are the outside walls as you go around it. It's the only thing it can be.
Okay.
Okay. So if I'm doing that, obviously they got a section here, 3-11. So I'm looking at 3 and 3. I have no idea why they call it 3-11, but they call it 3-11. So basically speaking, I'm looking into the wall toward the right-hand side. So that puts this thing here up there and this one here right here. Okay. So those have to be the outside walls. So I just go look at the typical reinforcement, actually the reinforcement for all the outside walls, 7-12 and 6-12, and then the inside wall, 7-12 and then 5-12. So they just made the bars going horizontally one bar size smaller. I'd be very confident that that would be the answer. Here's how I'd approach doing this. You get, because they're just asking you questions about E8. I actually think that's pretty darn easy. You just look, I got a plan here. Okay, this is the plan. These are the dimensions. I got a section cut. Okay, the section's cut just like I said, it's right here to here. So I'm turning, it's going off to the right-hand side of the drawing. So you go look down below, and so like I said, this wall belongs here. This wall belongs, this one's pretty simple, runs there. This wall here belongs right there. Okay, and now I just start trying to understand that. And I could dream up a whole bunch of questions for this.
Dan?
Fun. Yes, Ed.
It does. Every single question will say on drawing E8, on drawing E3.
Okay.
So you could just sit there and look at it the whole time. I know there's a question, if these are them on the waste treatment plant, that has something to do with the general notes as far as what does this sit on? And I put my answer on native soil. You can see that in the general structural, and the other guys that took the test with me, said it was wrong. So I was wondering if we can go through these general notes maybe.
Okay, let's do that.
It's hard to see.
Our first note says all reinforcing bars shall conform to ASTM 615 grade 60. That's pretty easy. All concrete shall be proportions by laboratory test. That's pretty easy. Batches shall conform to the requirements of controlled concrete. Whoops, I keep forgetting you guys. We're in PowerPoint mode. Okay, 1, 2, back. You know what? Let me do this. Let me get out of that and go to E8 on here. I'm trying to look here and see what you could find out. No backfill shall be placed against any substrate walls until walls have obtained specified strength. So that has nothing to do with the substrate. Concrete protection of reinforcement shall be as follows. And they're just telling you what the cover has to be, 1.5 inches for a number 5 bar and smaller, 1.5 inches for number 6 bars, 2 inches. Stirrups and ties, 2 inches. Principal reinforcing, 2.5 inches. Blah blah blah. And footings, I don't see walls 2 inches. I don't see anything there. So let's keep moving.
I think the question they were talking about is on drawing E8.
Okay, that's good.
That's what we're on, isn't it?
Well, there's E8. I'm looking at E8, and there's E8A also, by the way.
Okay, there's I think the drawing he's where he's talking about what's underneath it is the foundation drawing for the sewage treatment plant.
Correct.
Are we talking about undergrain aggregate? Is that what it says there?
It's for the sewage treatment plant. I don't think this is it, is it? Yeah, that's what I'm talking about.
Same thing, okay. So that's where we're at, right here. So here's
No, not that.
Not this drawing?
Oh no, you're right. You're right. Sorry.
Well, you're not catching up to me as fast as I can click.
That's what it was.
Yeah, it just takes a couple seconds. Yeah, I'm sorry. So if you're looking at, you have underneath this slab, looks to me like you've got 2 inches of work mat. You've got.
That's what the question said. Is what does it sit on?
2
like what is the makeup underneath?
Okay, so it's probably okay. Do you is this a B C D F type thing, or do you actually fill in blanks?
No,
ABCD.
it's like okay, ABC. Yeah.
Okay, yeah. So under here, you've got a 2-inch work mat. You've got under drain aggregate. What else? You got a polyurethane membrane. So really, you have 3 things that are going on underneath that: some aggregate, a work mat, and polyurethane. Maybe that's the answer. That's probably the answer they were looking for.
So what would you say it's directly underneath the slab? All 3 of those, or
actually directly underneath the slab? I'd say it's polyurethane. If it's right under it, that's polyurethane. Then you've got between here and here, you've got some aggregate, and over here you have a 2-inch work mat. So this 2-inch work mat, they don't say that work mat looks to me like it does not extend across this aggregate base. It's only underneath the footings.
So basically that's a vapor barrier over ABC.
If you want to call it ABC, yeah.
Aggregate base cores.
Aggregate base cores, yeah.
Okay.
But do keep in mind, that's not on the drawing, so that would not be an answer for a question, the ABC.
Correct. So to answer the question, I believe the answer would have been polyurethane. If I had to choose, and I don't know what the ABCD is, and hopefully they didn't have A is polyurethane, 2 is undergrain aggregate, 3 as 2-inch work mat, and 4 that are D as sub-base material or earth. So if they had it that way, actually it would be easy. You just look on there and see polyurethane arrow goes right to the under part of the slab.
Can you go to drawing E7? Because I kind of remember a test question in there.
Yep, where you at? Okay.
Yeah, so there's a test question in
this...
here. You got to find it by, okay, so in the bottom left corner of each one of those, you got your 1, 2, 3, 4, 5, 6, 7. And it, man.
Bottom left corner.
Of each beam and girder schedule. In the bottom left corner, so it says 1 and then 2 and 3, and it counts every little section.
Oh, okay. I see bottom left corner. I was going right. I'm dyslexic. Okay, I got you. I see it now.
And so then you got to find it. And so let's say you're at number 7. It says S4B4, correct?
Number 7. 1, 2, 3, 4, 5, 6, 7. Right here. Okay. Looking at it.
Okay, and then it had questions it had one question. I can't remember exactly.
Well, there's 3 things going on here. So, okay. I can see it right away. So when you're looking at this 7 area, and I presume 7 to be this little whole thing, okay? And you see an S number, S4, 4, and 4. So what would you think that means, Mark, S4? or not Mark, but Ed.
You're going to go to your slab schedule and
Right,
look
so
up, and you can find your depth, your bottom.
Right, so you get your bottom bars, your top bars, and temperature bar, what they call temp means temperature bars. These are just the bars that are in there with a little bit of expansion and contraction from thermal changes. So that's where that is. Do you understand what all these numbers mean?
I don't.
I know that. Okay, so if it says 4, the depth is 4. I'm guessing 4 feet or 4 inches.
It'd be 4 inches. It would be.
And then you've got 4 inches, and you got number threes at 12.
You got number threes at 12 inches on center.
Number threes at
on the bottom.
Yeah, and that's your bottom, and then your top means obviously above it, so it's like a mat.
Mm-hmm. Number 4s at 12 continuous across the top. Now, when you look at your number 4s, you're coming across here. This is your bottom steel, looking at this beam over here, okay? You're looking at here's a beam. There's a beam and a girder. You see this is your top steel, and it goes across the center of the beam because that's where your flexural, your what they call a bending moment is across the top. And you just think of a 2x4 and you stand on it. You stand on it, it gets lower in the middle, right?
Mm-hmm.
Okay, but the edges are still in the same spot from the support. So the stresses kind of come across the bottom, then the stresses come across, the tensile stresses come across the top, then they go back across the bottom. So they're telling you that these are the number across the top. They're number 4s, number 4s at 12 inches on center. It says continuous and it says end. I don't know what that end means, so there must be a size or a length of that somewhere. Okay. In fact, here it tells you right there. It tells you what the sizes and the lengths are. And same thing with the bottom. The bottom is coming across all the way across here. Okay. So that's how you read that one. And then we're going back up to 7 for a second. And we got a G2 and a B3. So if we come over here to beam and girder schedule, and we come down to, what was that? Let's look at the B2 first. B2. And B2, got to go up to the top. Looking, you got sizes, length, and width and bottom. Okay. So B2, it tells you it's 12 by 22. So it's 12 inches wide, probably by 22 inches deep. It's got number 7s coming across there. And that's the A bars and the B bars. When you say A and B bars, they're talking about someplace over here. See, they're telling you here, A and B bars. There's the A bar on the bottom. There's the B bar on the top. Just a little bit different apart, okay? 2 inches clear. All right, so it tells you what those bars are. Some go from one support to the other, and the other one just come across a little bit. And what they're doing is translating these stresses that are coming across here into up there. The stresses start going from being in the bottom, that we'll call it tensile stresses, from being in the bottom to start going across to the top. Okay? So going back up there. And then it tells you B2, you've got, tells you what the 2 number 8s, and they got non-continuous, I don't know, whatever to the end. 4 number 9s come to the end. Then they tell you what the stirrups, and up there you see the stirrups and ties for B2. I think it's this one we were looking at. Tells you what the sizes of those are. You got 16 number 3s, and then it tells you what the spacing is. You got 1 at 2, 2 at 5, and 5 at 8 inches. So what that means, confusing, I'm sure. Coming across to you, you start one at 2 inches, starting right here, starting 2 inches out. Then you have one that comes out or 2 at 5, so you have 5 inches and 5 inches, 2 bars. And then the rest of them are at 8 inches on center coming out across there. That's what that means. So there's a lot more, the reason they do that is they have a lot more shear stresses at the edges where all those we can think in terms of loads are coming in we'll call it turning direction to go down into the concrete, down into the horizontal or the vertical portion of the concrete, if that makes sense for you.
Okay.
Okay? And the girder is going to be the same way. You would just simply, you got a 14 inches wide, 32 inches deep, A bars and B bars. You see them coming across there. They tell you what the top and the bottom bars are. They tell you here, the stirrups, because that'd be a really good question to see if a guy understands stuff. I'd say, what's the, for G1, what is the spacing for the stirrups? And it's not a simple answer. It's 1 at 2 inches, 3 at 6 inches, 3 at 9 inches, 2 at 10 inches, and 2 at 12 inches coming out across there. So somebody's got to do, you as an inspector would definitely need to understand that. So you go out there and look at the stirrups and make sure somebody just didn't put them all at 12 inches on center. That would be a potential structural defect. The building probably won't fall down, but it might start cracking because of not having enough stirrups across there to take care of the shear stresses, and the shear stresses will start coming up as kind of like 60-degree cracks coming across the beam at that spot. That's typically usually an interpretation of having not enough ties in there.